My name is Anthony Milosla, and a little bit about myself. I'm actually a recovering enterprise network engineer. I'm in the New York area, but Chicago is actually very near and dear to my heart. I've spent many years building networks for a certain financial exchange down the street. So I think I have a pretty good perspective when it comes to, what does automation look like in a large enterprise? What does automation look like in an enterprise that's really not ready to move? What does it look like when most of your team doesn't really know Python? When some of your engineers have zero interest in learning automation or just, using any kind of repeatable way of managing their network? So just for starters, you see a lot of terms thrown around when we talk about automation. Infrastructure as code, CI/CD pipelines, scripting, and a lot of engineers that are experienced with automation, they understand the nuances. They understand what's behind the scenes, what's the advantages and disadvantages of each method. But for other engineers, you see these terms thrown around, and I realize that a lot of engineers don't pick up on the nuances. They don't really understand why is one method better than the other? What do you get from, going from just, basic scripting and playbooks to actually infrastructure as code? So why are we talking about testing today? We're going to talk about testing because in the context of infrastructure as code and CI/CD pipelines, terms we're going to dive into and define, I think testing is one of the most neglected, as you saw in the title of my presentation, one of the most neglected pieces when it comes to treating your network infrastructure as code. Testing is usually an afterthought. It takes so much effort and so much momentum for an enterprise to get behind pushing automated changes that when it comes to testing and that part of treating your network infrastructure, it's something that we're gonna figure it out down the line. And I'm kind of here to tell you that, it's much easier to think about testing when you're developing this infrastructure as code model. So a little bit of history, not very optimistic as you can see, but we're getting there. Why is networking so far behind? I think most of you know some of these answers. It's a shared infrastructure. You know about blast radius. There really is, especially in the large enterprise finance sector, a high-risk, low-reward culture, right? If you want to look, making your job a little bit more efficient and pushing out some low-risk changes just to get more familiar with automation, just to get your teammates more familiar with it, it's a high-risk, low-reward change. You're not going to get rewarded for it. You might advance in your career, but at that particular time and place, there's going to be, little reward for it. And that's really the reason why most engineers fear automation. And, just a little bit of a screenshot there where you see a router that's been up for 15 years. The old mentality of networking, the old mentality used to say, that's an amazing product. It's been up for 15 years, quality. The new mentality of networking and automation says you have zero idea about what's going to happen when that router breaks or goes down. Zero predictability. And this is that kind of mentality when you start automating and start treating your network infrastructure as code and start testing. This is really that mentality that needs to change. Not these devices that have been up for years and years and years and have zero predictability about what happens in the outcome of them crashing or you having to upgrade them. So a little bit of history. I think most people are familiar, and you can agree, disagree on the various contents of these slides. But I think the point is, we started with screen scraping in something that was, not very accessible to most engineers. Some various forms of expect scripting. Move towards Python scripting with modules where a lot of the work is already kind of done for you. You just have to add your business logic. And the module that is already written for you will handle the transport between yourself and the device. As we're moving more to the right, you can see that we're adding more abstraction. And you can argue whether abstraction is a good thing or a bad thing, it's both. But abstraction lets less experienced network engineers get started with automation. It makes things a little bit simpler, and it makes things a little bit more shareable between the team. So, you know, why is there a move towards infrastructure as code? Why are scripts and isolated playbooks, why are they not good enough, right? So if, you know, if your enterprise is doing some form of automation, chances are in 90% of the cases, you're talking about automating some kind of mundane tasks, right? Whether it's to push out a change to 100 devices and not having to do it by hand, right? That's what we're talking about. We're talking about isolated scripts and playbooks. So the pro of this is that it's an imperative approach, and there's actually minimal layers of abstraction. So you know exactly what that script is there to do. You know how that script can fail. You can write unit tests for that specific task, and things are pretty straightforward. Now, how does that really work if you want to manage, you know, a portion of your infrastructure, or maybe even your entire infrastructure as code, right? How does that really work? Are you going to have isolated scripts, isolated playbooks, push various pieces of your configuration? Are you going to have your coworkers read your Python code or read your, you know, playbooks or whatnot and understand everything that's going on, you know, without a detailed explanation? You know, not really. That's really where enterprises start to go lackluster and start to fail. And this is really the reason where, you know, every networking team has that one guy sitting in the corner doing scripting. And, you know, if that person leaves, basically their scripts are going to go die in a corner. And we've seen this story many, many times. It's really repeatable and predictable. So that's really where infrastructure as code comes in. You are adding an abstraction layer, but for the cost of that abstraction layer, you're making things a little bit more readable, and you're actually able to manage your network infrastructure as code, all of it. Now this has been made much more popular, I would say over the past 5 years with the public cloud vendors, where you're either doing infrastructure as code in the public cloud, or you're just not doing public cloud correctly, right? There's no in between. There's no isolated script. And so taking that mentality and applying it to networking, there's, you know, numerous benefits of how infrastructure as code gives you that predictability and that way to manage all of your configurations, right? Taking, you know, a talk we had earlier this morning, taking a source of truth and having that source of truth, whether it's a database or an IPAM tool, store all of what you think the network config should be, not what's actually on the devices, and constantly push that state out. All right, so various benefits, I think, of the infrastructure as code model. So what does a workflow look like in an IAC model? You have an admin. He, you know, there's a templated file. He makes a change to that file or an addition to that file. Code is committed to a repository. You have some type of configuration automation tool. Go push it out, and your change is pushed to your devices. So, you know, kind of taking a step back here, and we're going to dive into this a little deeper. You know, thinking about specific scripts and playbooks. If you have a specific script out there to push, I don't know, an NTP change or an SNMP change or, you know, something out to a bunch of devices, it is really easy to test for the success of that change, right? It's really easy to test for the success of that change because you know exactly what you're changing, what you're expecting to change. Now, in infrastructure as code, that's actually not the case, right? Because you have this general template, this general definition of everything that you want to define on all of your devices. So in theory, ahead of time, you really don't know what change you're going to be making in a specific commit. So something to think about when you're talking about testing is that this is a pretty high-risk change when you talk about treating your entire network infrastructure as code. So how do we go about testing it? This is our end goal, and I think this is a good point in the presentation to mention it because it's, you know, we know where we're starting, and it's really nice to have an end goal in sight, right? So you have an engineer commit a piece of code. There's some kind of peer review or change control process. You do some kind of automated testing. You push that config change out. Whether you're provisioning brand new switches, whether you're making a change, or maybe you're replacing a piece of your infrastructure. You do some automated testing afterwards, and then you monitor. And this is that continuous cycle that adds predictability to this process. So the common question is always, if the systems and the mature cloud teams, if they're so many years ahead of where networking is, well, what are they doing? Why can't we just take their process, copy it verbatim? This is a kind of a solved problem in that part of the land, right? So how do we take what they're doing and apply it to networking? So let's kind of go through some steps of what this would look like. Does this really translate to networking, right? If I'm a developer and I push code to dev, I do all kinds of testing, that gives me confidence, right? That when I push that change out to my other environments, to production, that this has been through numerous iterations, I have confidence that that change is going to succeed. Does this translate to networking today? Well, you can have your automation tool push out a particular change to your dev environment. And, maybe that gives you some confidence to push it out to your production environment. But, let's be honest. Dev environments are rarely copies of the production environment. This is honestly what your testing is going to look like, right? You're going to simulate this change in a lab, and your infrastructure might match 40%, 30%. And hey, it's better than nothing, right? It's better than not testing at all and just pushing that change to production. But this is what network engineers, for the most part, have to deal with today. So if we're going to do testing, if we're going to take infrastructure as code and put testing behind it, this is really the place where CI/CD pipelines come in, right? Pipelines take repeatable steps and add repeatable tests to your infrastructure. That way you know that if you make an infrastructure as code change, there's going to be a repeated process, whether it's a change control process, whether it's various pieces of tests. These are going to be the exact same repeatable tests that run every single time. And this gives you just a little bit more confidence that when you're pushing out a change, you've ran through your collection of tests, and you have a little bit more confidence that that change will succeed. So what kind of tests can we use, and how do they really apply to networking? Let's start with kind of the easiest and the smallest way of testing, unit testing. Right, so unit testing, you break down the problem into really small pieces. That way we can do these really quick tests and get answers. So for example, as you see here, I'm adding a VLAN. Let's confirm that that VLAN was added successfully. Or I'm adding a new BGP prefix to my prefix list. Let's confirm that I'm advertising or receiving that prefix. So unit testing is really easy to do when you have specific scripts or playbooks that do one action or two actions or three actions, and you kind of know ahead of time what that's going to be. Unit tests are a little bit more harder to pinpoint when you're using templates, when you're using infrastructure as code to push out changes. You really don't know ahead of time what to test for. So you kind of have some options. I mean, you can test everything, but you could see how that problem kind of fails to scale really quick. So what's a little bit more realistic that you can use in your pipelines to do testing? So that's where integration testing comes in. So verify how these various components are interacting with each other. For example, if I'm adding a new VLAN and I don't know what this VLAN is ahead of time, I don't know the VLAN number, I don't know what to check for, let's confirm that that VLAN addition didn't really do anything to spanning tree negatively in my environment-wide. Same thing with a BGP prefix. I'm adding a brand new BGP prefix to my prefix list. Let's make sure that routing looks healthy globally for whatever your definition of healthy is in your particular environment. The whole point here is that you're not targeting very specific use cases of, I pushed out a VLAN, is that VLAN there? No, you want to make sure that if some kind of fat finger event occurs, right, that when it is pushed out to all of your devices, you can at least catch it and catch these kind of massive impact changes either ahead of time or after the change. But the point is your testing will catch it as soon as possible. So, taking, what does a unit test look like, right? You have your configuration tool that pushes out that change. In this particular case, it's an NTP server. And you do a test afterwards, right? And you can use whatever tool you want. You can use Python, Ansible, whatever, right? The whole point is you parse your device config. You say, was my change successful, right? I made my NTP server 1.1. Is my NTP server now 1.1.1? And your test either passes or fails. So same thing with integration testing, right? You take your infrastructure as code template, you make a commit, and you push out a change, right? And that change goes out, and you do some automated testing afterwards. So what kind of tests can we do where I spoke about in terms of integration testing? What are some things you can do to test this infrastructure as code change? What can you insert into your pipelines that's going to run every single time you make a change, regardless of what that change is? And I think it's really important, at least for starters, to focus on these generic environment-wide tests. Measure impact. Make sure that your one small change didn't accidentally get pushed to 100 devices when it wasn't supposed to, and didn't affect something that you didn't intend for it to affect. So for example, it's really these generic and reusable environment-wide tests. This is what you can integrate into your pipeline, and these are the kind of tests that can run every single time you make a change. So for example, your overall layer 2 or layer 3 protocol health. Any weird MTU mismatches, environment-wide. The number of routes, is it where you're expecting it to be, or are you by some chance, advertising or receiving 500 extra routes than you expected to? Things like NTP status. And honestly, testing, the way it works is you insert your battle scars, right? It's impossible to take a particular environment and test everything. And when you do have issues, when you run into various, network events over time, there are going to be certain things you want to test for. And this is really how you build your testing suite. You take what's important to you, what adds business value for testing, and this is what you add to your pipeline tests. So let's look at the Cie Cd approach, right? What does this look like? We take a piece of code, we commit it. We have a build tool, whether that's Jenkins, GitLab, something that's going to go out and actually, based on a commit, push out a particular change. We deploy that change, and then we test what happens afterwards. So taking a piece of code, let's just do a really simple YAML file that we're going to use Ansible to interpret this file and push it out for vendor-specific config to a switch. Right, so we have a couple of ports defined, some BGP information. So we make a change to this file. Right, on the right-hand side, you see an example of a template that looks at the values in this particular YAML file, and based on those values, based on the device, makes these, populates these configurations. What a GitLab, build file looks like. It gives you the freedom to define your stages, right? So in this particular case, we're just going to have one stage. We're going to call it deploy. And what the deploy stage is going to do is it's going to call this Ansible playbook. And the playbook is just going to push out the configuration change, right? We're not doing any testing here, but this is kind of the building block of building that pipeline. Okay? So taking this templated file, we're going to have an actual task in the Ansible playbook that's going to push this configuration out using the template. And finally, how do we do a test? We can do something as simple as, looking at the BGP summary on all of our nodes, right? And just make sure that, sessions are established and that our change didn't do anything negative. And this is a BGP example, but you can take this to check anything you want, honestly, on the infrastructure. Okay, so finally integrating that into our build tool, into GitLab, now we have an additional stage. Not only do we have the deploy stage where we push out the configuration, we have a second stage. It's a test stage, and the test stage is just going to run this test Ansible playbook that we just looked at. right? Keeping it very simple just for the purpose of this. So I guess the main question is this good enough, right? We make a particular change, we go ahead and test it, right? Is this good enough? Is this going to prevent kind of us, fat fingering various changes and pushing them out to hundreds or thousands of devices? What else can we do? What can we add? So this is where the pre-change testing kind of section comes in. What can we do and what can we possibly add to our pipeline to make sure that we do as many tests as possible before the change is actually pushed to production? So we're going to start with some of the simplest ones and kind of build from there. So linting, right? Looking at your particular YAML definition and just making sure you didn't insert extra spaces or any kind of other values where you didn't intend to be. Pre-commit diffs, right? So various vendors support this. You can try to simulate a config push and see, does the device gives you what you're expecting it from a diff perspective? Is it giving you an error? All before actually pushing the change to production. Ansible has something called check mode, right? This is kind of easy things that you can do before pushing out your particular change. Getting a little bit more mature, now we have prediction tools. There's a couple of vendors here, but there's an open source tool called Batfish as well. And Batfish really, and all these tools do some version of this, is they take your configuration data, and some take your IP route output and so on, and they make predictions based on what these configs suggest, right? So there's a lot of information you can gather by feeding your configs or your proposed configs to these tools and getting information out of them. Am I changing something I'm not expecting to change? And this is all, once again, pre-change testing, all before we actually push the change to the devices. And finally, simulation. And we're going to quickly dive into simulation in a couple of slides. So here's what our updated Cie Cd approach does, right? We add a new little box called pre-change testing. And this is the collection of these various tests. They're not mutually exclusive. You don't have to do one and not the rest. Feel free to do as many as you're comfortable with. So now you have pre-change testing, so you have a little bit more confidence that the changes you're pushing ahead of time, it gives you a little bit more confidence that nothing's going to go wrong. All right. So a quick thing on simulation. We saw that slide about how do these mature ops and mature cloud teams, how do they do CI/CD? And there was a little bit there in the middle about Docker and test. So how do we take what these development teams do with Docker to kind of bring up this container, simulate a piece of code, run tests against it, and get an answer? How do we take this and how do we integrate it into networking, into the pipelines? So that's honestly where simulation comes in. And bear with me here. Simulation kind of is still a relatively new area, and a lot of network engineers kind of scoff at it. I know I personally did when I first saw it. So if we can simulate, if we can bring up a piece of the network, virtually ahead of time, and simulate our proposed change against that simulated network, all before ever pushing that to production, I mean, that'd be pretty nice, right? So that's kind of where the Microsoft CrystalNet approach, and this was published, I think, was it 3 years ago or so, where Microsoft took a simulation approach of using a combination, I think, of containers and hypervisors, and simulating their network, or simulating part of the Azure network. And what they found is, depending how you interpret the numbers, that 60 to 70% of their changes could have been seen ahead of time if they were simulated. Right? We're not talking about forwarding plane errors or kind of ASIC bugs. No, we're talking about pretty common errors that you can see. And if you just simulate this, if you bring it up in a virtual environment, you can catch these things ahead of time. So simulation, what's required? How do you take the your infrastructure and how do you bring it up? How do you simulate it? You can start with something as simple as your laptop, using Vagrant, VirtualBox. But you can really take this as far as you want, right? Your own bare metal, you can stand it up on public cloud. And there's various multi-vendor orchestration tools there, right? Vagrant tries to solve that problem. EVE-NG is another product that's in that space that's very popular. And I think the main question is network simulation ready for prime time? All vendors have some form of a virtual appliance, right? The virtual version of their operating system. You know, some are hypervisor-based, some are container-based, some are bloated, some are large images, some are not feature complete, some are, right? It's still a pretty new, a new technology. But I think this is gaining steam, and I think this is really where we need to approach our network vendors and kind of demand that they add more attention to looking at these virtual versions. Because if you can simulate even a small part of your network, this really adds a lot of value when you're taking an infrastructure as code approach. Okay, so finally, what would our GitLab build file look like if we did some simulation? Right, so we're adding a couple of more steps here. We're building our simulation using Vagrant. Right here, we're just bringing up 2 leaf switches in our virtual simulated environment. We're running our playbooks and our tests ahead of time against that simulated environment. If that all succeeds in our pipeline, then we bring down this simulated environment and we actually push the changes to our production environment. All right, so last slide. What are some observations, lessons learned, you know, the various kind of ahead of their time customers that have actually used this for their environments, right? What have they learned? What kind of, you know, is any of this ready for prime time? And I think the main thing is, as with many automation parts, is that break up the problem into small chunks. You know, whether you're treating your network infrastructure in pods, maybe you want to just deploy this on a couple of switches and see what this looks like. Separate inventory files, right? Separate branches for simulation, right? You want as much control, especially in the beginning when you're starting to deploy this. And as I said before, new tests really stem from those battle scars, from what's important to you when it breaks in your network. And you can add this into your testing pipelines and go from there. All right. Any questions?